guys, welcome back to the channel. So now we'll be talking about Nazar server. And so why did we use the server? Because if we use server, then we have to send this image back to the HTTP request and then look into this web server, and then it will send us a response from about the data. But we tried implementing it using an offline model using React Native TensorFlow, but the mobile processors are not quite up to the point, because we'll already be using React Native and not native element, and on top of it we are using TensorFlow, and different mobiles one may be able to support. So we are using an online server which creates this 100 MB size to a 10 MB, and we can use it in less memory and space for older SDKs, and it will be easier to upgrade within a server than create individual APKs and download it. So how it will be using it is, we'll take an image in 1 second and with a quality of 0.1 using React Native camera, and then send the base64 encoded text back to the server, where it will decode it into PNG and then resize it into 299x299 pixel, and then the tensor will be feed into this session with retrained graph and squeeze the image, and then the topmost result will get the result and the prediction value, and then it will source into this octopart API to get different specs, and then it will return us the dictionary. So let's look into this coding part. So as you can see, this is the main classify.py, where we'll be using this directory of tf files, which is right here with this retain graph and retain text. And I've already defined the train.py otherwise, and you can use this particular repo only to use retraining and also for server. So classifying, we'll use this working directory, and then this temporary directory is only used for retraining if you want to use it. So let's look into Nazar server right here. These are the types of using it, and this retraining is already defined, so I don't think I have to use it. And this is AWS screenshots, and you will be using this post request example, which you can use already from terminal, but we'll be using React Native application. So let's look into this server. I think I've already seen it in here. So what we'll do it is, we'll just send this application Java to image64, where and this is defined as base64 integrated text with this validation of data image additionally added, which will cut it in from the server, and then we'll send it to this Nazar server or heroku app classify image, where it will define this. It is as LED with prediction of 85%, and then sort information with along with different manufacturing data in descriptions, and send back this dictionary. You can view it from logs also. Here we'll get this data, and then it will send us back the dictionary. So let's get back into coding. So now retain graphs is defined already from here, and retain labels, and this will be the default input with hide, SSD and mean. So initially the app will take this graph, and then the input name and output name for tf of classify within section v3 is placeholder and final result, and then we'll get this input operation, output operation setup. And then if you send an image to classify image, it will get set in its post request, and then we'll get this data which is defined from here, data and image64, and here is this data. So from data, if there is information, we'll save image of this base64 which is defined here, save image, where it will just crop out this additional padding of data image JPG base64, and then it will just create this file name and save the data and return us the file name which is defined here, and then JSONF will send this path to score where score will create a tensor from use file which is defined here, where it will just take the file name and then return us with this reduc expanded precise normalized value, and then it will be fed into this session with input operation which is defined here to get the graph operations, and then the top result of single data will be stored with the label and compared, and then if there is a value, then we store the label and results, and then set it in data which is defined here, and then return the data back to the classify, and this will get the data, and then this JSON 0 value will take the LED prediction value which is defined here, LED, and the JSON-F1 would have taken this prediction value. So the JSON-F will search in octopart for general, and then all we want from here is a particular UID which we'll be using it in the second search with different specs, image sets and descriptions, and then we'll look for JSON in this particular specs, and then we'll take these specs and descriptions, and then we'll send back the dictionary of indent with all this component, prediction values, sort information, octopart URL and different information back to the app. And now in next video we'll be looking into this app as to how we'll be showing this computer keyboard and different details back from the server. So I'll see you back then.